So, as Ariel mentioned, we are brothers as well as doing cybersecurity together. We are going to talk today about how we hack bridges. We think it's going to be extremely excited. We have a lot of innovative and new approach. At the end of the lecture, we're also going to talk about a bonus part. This is a new exploit we found in a bridge. We found it, we published the blog post today for this summit, so this is the first time you're gonna hear about this hack. I'm not gonna ruin with too much spoilers. Yes, let's start. So, a little bit about me. My name is Nir, I'm the CEO and co-founder of Sayfer. I founded a company alongside with all. I myself, a hands-on cybersecurity hacker. I'm a white hat hacker. I love to hack things. It's very exciting for me. And also, Or, talk about yourself.
Yeah. Thank you. My name is Or, Nir's older brother. I founded the company with Nir 4 years ago. I am a white hat hacker as well by heart. This is how Sayfer started. I'm doing a lot of hands-on technical research, security research today. The title is CTO, but again, a lot of hands-on, as well as some people management in the background.
Great, so maybe a little bit about Sayfer. We as a company help other companies become more secure, basically by hacking them. So we do penetration tests, audits, and we hack companies for a living. I think I'll start with other presentation while we are at the background. The reason why we talk about bridges. So probably some of you are already familiar, and maybe it's a good time to ask, how many people here from the audience have ever did any transaction using some sort of a bridge? Wow. Yep. I expected way less. Maybe like 2 years ago, no one would even know what I'm talking about. So bridges get much more hype and much more usage every day. And this is why we basically decided to talk about bridges. And the more important part is bridges security. As you can see, more and more bridges are being hacked every day. Chainalysis talked a lot about the report. $2 billion is being stolen. And we try to understand why this is happening. So, next. The main reason, they have a lot of money. A lot of money. $25 billion is being held by bridges. Yes, there is a maybe short decline to the moon here that in but before this, tons of money was being put to this bridge. More and more money. Sorry, guys. When more and more money is being put to these bridges, it becomes a much more valuable attack for attackers, a high target, and they decide to target this.
Another reason is because it's complex. Building bridge, and a lot of you are developers, so you probably know, building bridge is not easy. We're talking multi-chain communication. We're talking a lot about events. There are smart contracts on both chains, and they need to communicate with each other, and it's not easy to make. When you have complex systems like that, security vulnerabilities arises, and that's why we think that it's happening a lot in those bridges. When complexity comes, you also have vulnerabilities. We want to go over our methodology on how to audit a bridge. It's not just a smart contract. Bridges, like we said, is more complex, and we want to have a step-by-step breakdown of how to do that.
Yes, so I think the most important part when start deciding how you even approach attacking a bridge is understand the security model of the bridge. So Hadar before mentioned about it, but is the bridge trusted? It is very similar to centralized exchange where some of the parts, there is one government component that decide who can move money from one chain to another. Or is the bridge trustless? Is there a consensus mechanism and validators that transfer the money from one blockchain to another? These parts are extremely important where we come from in order to decide how we're going to hack this bridge. Let's talk about key management. So if it's a trusted bridge, basically 5, 10, 20 people, I don't know, based on the protocol, have the keys to sign off transaction from one blockchain to another. It's extremely important for us to understand where are these keys, because you can see from the running bridge attack, 4 keys out of 9 that can sign off transaction were on one computer. This computer got hacked and 600 million, I think, got stolen. So it's extremely important for us to understand where these keys. But if you talk on the trustless model, it's way different because it's decentralized. There is no one key, there is no one government that control the transfer from 2 blockchains. So you need to ask yourself who signed the transaction? How do they do it? What's the consensus mechanism? Is the algorithm make sense? How many nodes there are? Then we go to the validators, which is very similar to what I've just mentioned. Who they are, how do they work, how do they do peer-to-peer communication? You need to ask a lot of questions regarding the model and what happened behind the scene in order to even start and exploiting such system. As I mentioned, they're extremely complex and you need to understand them deeply.
So Nir talked about the project overview, and after you understand the project overview, you want to talk about the code base. Now there are a couple of components around that. The first thing you need to do is to read the documentation. Bridges are complex, and usually the team document everything because of this complexity. Then talk with the team, if you have the possibility. This is super helpful. It helps to reduce the feedback loop. Where you have a question, you're not sure about something, you can talk with the team and get answers quickly. Deployment scripts are super important. Read those because sometimes the vulnerability arises only from the deployment scripts and not directly from the smart contract. And this is super, super important. If you could, and I hope you can, run it locally. You don't want to do anything on public nets, either mainnets or testnets. Everything that is public, everybody will be able to see it, and if you find a vulnerability, you don't want it to be out there. Look at the tests. Tests are super helpful to understand the code base, but also later on to try your exploit and vulnerabilities tests, because you don't have to reinvent the wheel. You have tests with all the setups and teardowns. You could copy a test, change it, and test out your exploit. This is super helpful. And maybe the most important component is the last one, which is reviewing end-to-end transaction flow. You want to understand from chain A to chain B how everything works, how it goes. When you understand that, you understand the bridge. So we are still in the realm of architecture, and we want to understand the smart contracts. And plotting a function call graph is super helpful to understand that. This one is like, we have 2 examples here. On the right, you can see a simplified smart contract. We use Surya to generate it. And you can see all the function calls on the smart contract. Payable function has a red cycle around them. And if you want to dive deep in a specific function flow, like on the left, you can click on one function and it will highlight only this specific flow, which is super helpful because sometimes you need to dig deep into a specific flow rather than look on the whole picture.
Another very, very important part, and this is true for any project you do and any security audit you do, and when you look for vulnerabilities, is understanding the diff. Every code, and we all developers, we all know it, every code in existence is basically a copy-paste of other code. And we want to make sure where the code was copy-paste from, how much has been changed, the original, the source code was secure, because if you copy a code from one of the main bridges, we can assume it's relatively safe. It doesn't mean it can get hacked, but it's relatively safe, more safe than what you're going to develop in-house. And then we need to understand what you copied and what you've changed, because the parts you've changed, even if it's one line of code, and sometimes you think, yeah, I've just changed small minor change. It doesn't relate to security. It's not going to affect anything. And this is how you get hacked. More and more for clients, we see only the diff, only the difference code that they added is the part we find the vulnerabilities in. This is why we focus on these specific parts. And it's so important that we actually develop an internal tool for it, and we decided to publish this tool as an open source. So basically, smart differ understands solidity. We hope it's going to support more and more blockchain-related programming language in the future. We will going to post the lecture and a link to this if you want after this presentation.
All right, so you understand everything on the high level, and you check the diff, and now you want to run some automated tools. This is super important and easy, relatively easy, because you just run a command and it scans your code for vulnerabilities. Well, this is very important, and the most used tools is Slither or Mythics. What I don't want you to do is to run this tool and hope there is no red lines. And like, sure, yeah, you can run the tool and there is no red warnings, and it doesn't mean you're safe. It is a tool that helps you to understand your smart contracts, and you need to use it as a tool. To help reduce the noise, we added a couple of flags for Slither, which helps you exclude dependencies or specific paths or specific dictators that you can exclude from your scan that you don't want to look. You can also use the output as a JSON format, and this is relatively easy to then filter and do a specific to-do list for you rather than see all this output in your terminal. And if you found something on those tools that you're not sure about, Slither, for instance, has a wiki links, which are super helpful. You can learn from that just by running it on your code.
Another area you want to make sure you check in, and this is extremely known for security research, but I think not many developers are aware of this part from security perspective, is errors. Anytime I, as a person who like to find vulnerabilities, see an error, I understand something occur in the program that it's an edge case, and these edge cases are very good place to find security vulnerabilities. And we even gonna explore this specific part in the next section where we show vulnerability we found, because this is a great way to understand the edge cases in code, and then we start to analyze these errors, and it's extremely easy in blockchain as everything is open and you can see all the error logs. When you see an error code, one time, if it's made sense, okay, if it's an error code due to not enough gas, yeah, sure, it's made sense. But if the error code is something that's not supposed to happen that much, if it happens a lot, you need to investigate. You need to start do some forensic work to understand why this is happening. Great way to do it is either via Etherscan, where you can see all the error transaction, or you can directly do get logs from the node. This is two great ways to analyze all the logs that happen in specific smart contract.
All right, last step, but maybe the most important one, is the manual audit. Up until now, we learned about the project, we run the automated tool, we plot the function call graph. We have everything ready to do the manual work. So you review all your notes and everything that you learned up until now, and you start going into that. This is your starting lead points, and it's helpful to start on a big beast smart contracts list like bridges, because you know where you should start. You don't want to go too deep on a specific path, because sometimes you can spend days on a specific thing that you think you found a vulnerability, but in reality it might be a dead end. So you want to go wide and try to find everything that's possible as wide as you could, rather than go deep. Another way you can support your manual work is use Slither printer. The specific one is the data dependency printer. It prints the function dependencies for every variable that you have. So right here we look at specific function that have a couple of variables. And let's take a look on the last one, the percentage of fee. I can see which other variables affecting this specific one. So if I know that I can control the stake amount, for instance, and this is a user-controlled variables, and I might be able to exploit it, now I know I can also exploit the percentage of fee because it has a dependency on it. This is a nice way to look on smart contracts without looking on the code that might be a bit more complex to look, and this is more of a high-level overview and a helpful tool to check out the actual logic. Another way is to use the Surya MD report. It has a lot of things. One of them is the contract description table, which gives you a nice table. It's in a markdown format. A nice table that's for each function tells you the visibility, is it external or internal or private, the mutability, is it changing state variables, and then the modifiers on the right. If you look on this specific example, you can see the change owner function is an external, meaning everybody could call this function. It's changed the mutability, changing the state variable, which makes sense. It changes the owner, but it does not have any modifiers. And this is a big red flag for me as an auditor, because this means everybody could change the owner. Now, this is a red flag. Now I will go back to the code and check what's the logic there, but from here it doesn't look so good. And these tools give me a really quick way to go over all the functions without needing to read the code and look for it.
So after we learned a little bit about our methodologies and how we hack, who doesn't love a challenge, we want to show you how you can apply. I know it was relatively fast, but I want to show you how you can apply what we just learned in the real world. So for our example here, we have the super secure bridge, and it got hacked. Like any project that gets hacked, it tries to learn from its mistake and implement new security features. Before it does it, before you implement new features, you need to understand what exactly happened. So they had some understanding that some way amount was deposited, but the hacker already took the money. So there was a mismatch between the money that was deposited and the money that was got out. The money the hacker made profit on their back. They decided to implement a new security feature called validate amount. So every time before you deposit money and the end user, you make sure they have the correct money. I know it's relatively sounds simple, but it's another security feature. Now we gonna come and together we're gonna audit the new feature to make sure it is fully secure. A lot of time, and this is very common in security, when people implement fixes, they actually create new vulnerabilities. And we know to look at these places, and we will show you how we look at them. So as you remember, we talked about the plot function troll graph. So basically, looking at all the function and who trolls who. And we also talked about the importance of checking the diff. We will use these two methods in order to find this new vulnerability.
So first thing, let's plot a graph. Like I said, we use Surya for that. Don't worry, we'll have that in a second when we actually start the audit. We can see here list of functions and what they call. We can see the deposit function that was hacked, the last one, now called also the deposit, but also the validate amount. So this is the fix that was implemented. Now we see that on a high level, but let's go a little bit deeper. Let's check the diff. And we see an interface that was got a new function, the validate amount, that's, like we said, need to be called before the deposit. So remember, every time we call deposit, we first need to call the validate amount. And if we keep looking on the diff, and this is the last one, we see the deposit funds function. It used to call only the deposit, but now it's also called the validate amount. So it makes things safer. Let's put it all together we want to give you some time to check it all. On the right, you can see the call graph, the interface, and the deposit function, the deposit function that was changed. So let's put some music, I hope it works, and give you a minute and a half to see if you can find the vulnerability.
Yeah, it's always best to work with some nice relaxing music on the background. Let's hope it works.
All right, no music, but לא חשוב, נסתדר. All right, so let's review. Let's look on the function call graph, and if you look on the top one, the validate amount, we see that the deposit funds actually call it and they fix it, and this was awesome. But if we focus on the deposit one, and just to make sure who calls it, we see that there another function, the deposit ETH, and this one actually not calls the validate amount. So it seems simple, but it's easy to miss.
Now, you might think, yeah, it's like very simple stuff we showed here, and it's not really applying the real world, but no, this is actually the meter vulnerability. Basically, Bridge got hacked for $4.4 million for this exact same vulnerability. We actually took the code, we changed very minor changes just so we can put it in one slide, but this is the vulnerabilities that happened there. Exactly from the same story we just told you, because they missed the fact that you control the function directly. Great commit of the developer, expensive bug fix. This is the commit that actually fits the vulnerability. Yes, so we talked a lot about our methodology. We went over how we hack stuff, how we audit. We then did a challenge. And now we're going to show you how we took this approach, what we know to the real world in order to find a real exploit in a real bridge. As I mentioned, this is the first time we're actually publishing this vulnerability. Of course, we safely disclose it to the bridge in order for it to not get hacked. And you're going to hear it for the first time. I think it's very cool. So before we even going to start about the vulnerability, we need to talk a little bit about front running. Anyone here know what front running is? Nice. So we will do a front running 101. It's a very cool, I don't know, it's something that happened a lot on the blockchain. A lot of people not aware of it, but a lot of money is being stolen using this approach. The approach is relatively simple. Let's say I'm a user and I see a very lucrative transaction I can make in order to make money. I see a contract that if I tell him, hey, can you give me one Ether? It's gonna give me one Ether. So I'm, as a user, send this transaction. Now, when I send a transaction, they're not being mined right away. I mean, now we are after the merge, so things gonna be a bit faster. But there's still a mempool, a place where all transactions are live before they are being mined, and they're waiting to miners to mine them. So I'm, as a user, sending my transaction, it lives in the mempool, and I'm waiting for the miners. When my transaction is in the mempool, a front runner, basically also, a lot of people also refer them as MEV attackers, front runners see my transaction and he think to himself, wait, I can make this money as well. I mean, there is only one Ether in the contract, but if I'm going to be faster, I can take it. So yes, chronologically, the front runner send the transaction later, but he does something very important for the miner. He send it with a higher gas value. Now, miners only care about their profit, and they only care about their incentive, which is gas. They see two transactions. They don't care anything related to the transaction, but they do care who of this transaction making more money. So the miner goes to the front runner transaction, and he first mine the front runner transaction, and only then he mine the user transaction. So at the end, The frontrunner makes this one iter, and the user doesn't get anything, as he was slower to be mined. This is a very simplistic example of what frontrunning is. There is way more complex attacks you can do with frontrunning in order to make arbitrage money on the Ethereum network. Ethereum is a great place for it as it's extremely slow. But even this simple, very simple example, it's what we're gonna analyze today. Now, short history lesson. The word frontrunning was originated back in the day about 100 years ago. People actually ran to the front desk to buy bonds and stocks. And when there was good deals, people tried to run in front of them. This is where the word came from. I think it's really cool. Today, we're gonna talk about the Connect bridge. This is the bridge we found a vulnerability in. It's an Ethereum Solana. It supports a lot of other blockchain as well, but we're gonna look on the Ethereum side.
All right, a little overview of how it works, and this is really a classic bridge architecture. The user send a transaction, a prepare function call on chain A. There is a router, an off-chain agent that listens to events for those transactions, send it to chain B, again with the prepare function call. The user then call the fulfill on the receiving chain, on chain A, again event, again submit the same function call on the fulfill on the second blockchain.
So as I mentioned, the first stuff you do is understand the bridge, understand the architecture, understand what's happening. After we have a brief understanding on what really happening technically in this bridge, we now go to a very important part we mentioned, looking for errors. And we actually did a different whole MEV research, and we stumbled upon this specific error. You can see the F19. And we wonder, what is this error? As I told before, errors not supposed to occur, especially not a lot of times. So we start looking at the bridge and at this specific contract, and we saw more and more of these errors. And we got extremely interested, why is this error happening? So we did some forensic. And best way to do forensic in this case is use the Tenderly Debugger. This is a great tool. You can basically see the line of code being lively debugged with the data from the transaction. And here you can see the transaction, the function that being called is fulfill. So if you remember from the bridge architecture, there is 3 parts. The last part is fulfill, where the user get the money in the receiving chain. Now, the reason for the transaction to fail is due to the require that actually made sure, and you can see, you can't see everything in this piece of code, but the reason it failed because someone was already took the money from the transaction. Now it's important to note the money that was being taken is the validator fee. So you basically receive money from moving money you receive fee from moving money from one contract to another in the blockchain. So here it seems someone was already receiving, someone was already sending the transaction and got the money. It was very weird for us, so we decided to keep on researching. And then we found what we suspected. We found 2 different transactions that has the same signature, the same cryptographic signature that the bridge requires in order to move money. And here we had a pretty good understanding why this is happening, because one transaction was sent first, but somehow got front run, and the second transaction by a front run or by a MEV bot sent later with a higher gas value and the same payload, the same data of the original transaction. This way, the MEV bot could get the fees of the validator and leave the validator without any fees. Here you can see a great example of 2 transactions. One is a victim, one is an attacker. And you can see a very interesting thing happening here, because as I mentioned, the only way to be in front of other transaction is with a higher gas value. Now, if you look at the transaction here, you can see the victim transaction have a higher gas value than the attacker. And you think to yourself, why is this happening? Let's see, no one here, is someone here as a clue? Yes, bribing the miners is a bit exaggeration in my opinion, but yes, you are totally correct. They use something called Flashbots. Flashbot is basically the ability to send private transaction that you can't see in the mempool. It's a complex protocol that called Flashbots, and in this protocol, the way you pay money to the miners is by directly sending them money. So you can see here, the last transfer is from the Mavbot to the Ether mine. It directly transfer money, directly transfer Ether to the miner, and the miner knows this, so this is why it shows its transaction first. Now, after we saw all of this, we want to understand how big it is, like how many times has this been happened, how many money was stolen. So we decided to do some blockchain analytics, which started extremely simple and became extremely complex at the end. As bridges are complex, there is a lot of different transactions, there is a lot of different currencies, and we tried to run on all the nodes, all the history, and then we had our results. This was way bigger than what we thought. More than 1,000 transactions have been front-run. This is almost 10% of all the transaction in the bridge. So if you think of it from developer point of view, every 10th transaction was front-run. It's extremely easy to notice it when you look at the error logs. I don't know how they missed it. And more than 70K US dollars, and this keeps on rising because it took them some time to fix it, was stolen. So this is what we found. It was a very exciting research for us. We started with one transaction. We had no idea where it's gonna lead us and how big of a finding we're gonna find. And this is how we ended.
All right, let's summarize. We started to talk by talking about why bridges getting hacked and why security in general is important for those bridges. Then we talk about our methodology and how we audit specific bridges smart contracts. Then we talked about real-life example of an exploit. Yeah, and I hope it was clear. This is time for your questions. So the question was, how did they fix it? The answer is they didn't fix it.
They're working on it.
They're working on it. We went through a bug bounty program. It took months. It was painful.
I think several ways they could fix it is, first of all, they could require their validators to run the transaction using Flashbots. So basically, all the transactions should be under Flashbots, and then they can't be front-run. If this is answer your question. Yes. Yes.
So what exactly do you do, and what do you do different from others? Do you prepare companies for audits, or do you audit companies?
So the question was what we do and how we are different from others. So basically, we hack companies in order to make them more secure, and as part of it, we do audits for their contracts. I think the main difference from most of the audit companies I've seen is that we try to look on the bigger picture. This contract was audited by Consensus, which I think are some of the best auditors in the world right now. But the vulnerability is a bit out of scope when you look on one contract. Because yes, the fix is in the contract, but the vulnerability is in the architecture as a whole. So we as a company try to look on our clients from 360 degrees perspective and find the places we as hackers would would love to hack because it's easy. So passive list resistance, we are extremely regressive about understanding this. It's a whole nother story and a whole nother talk to explain everything about it, but I think this is the gist. Go for it.
What's automating and what's project-wise? Because it seems like you need to go in my company, a whole project, 3 months, building and understanding what I do. Is that what you do, or do you have a lot of tools that help you with that?
So the question was, if I heard you, it seems like it's going to take a lot of time, basically, and it's complex. Okay, so there are a couple of ways to approach this. In the end of the day, when you look on complex projects, you come to conclusion that it's risk management. Sometimes you want to check everything, but you don't have the time or the budget, so you start cutting the scope down and try to come up with what's the most important thing. We understand that security sometimes is not the top priority. You're project-oriented companies and driven by your features and your clients. Security is sometimes in the background. We try to look at that on roadmap-based and budget-based approaches, and you try to cut down the scope to the most dangerous parts in your specific company.
Okay, guys, following up, you can come to me now because we have to finish. So the last thing we want to say, if you like hacking, we're planning on developing the CTF. CTF is basically a hacking game when you have some challenge, similar to what we've done here, a little bit more complex. We haven't finished, but we want you to, if you want, you can scan the QR and leave your email. We're not going to send you any related marketing stuff, so only the CTF. You can also view a link to the slide and a link to the diff tool. It was a pleasure talking to you. It was a pleasure teaching you about bridges, and I hope you had fun.
Thank you very much, Sayfer. Great lecture.